What's up, guys? Welcome to Nullvoid. Today we're going to look at a problem called climbing stairs. It's a problem being asked in interviews of companies like Facebook, Amazon, Google. So let's look into it. Let's look at the problem description. It says you're climbing a staircase. It takes n steps to reach the top. Each time you can either climb one or two steps. In how many distinct ways you can climb to the top? Let's look at the example. In example 1, we need to reach the second step. So there are two ways to do it. Either we can do like take one step at a time and reach two, that is the red line, or we can take we can climb two steps at a time also, so we can directly reach two. So there are these two possible ways to reach the second level. This red line and this yellow line should tell you how many ways there are to reach the second level. And if we look at example 3, like a second example, that is we need to reach n equals to 3, then there are three ways. Either we can take one step at a time, that is the red line, or we can take two step, like climb two step at once and then climb one more step, that is the yellowest line, or we can take one step and then takes two steps to reach the third position, that is the blue line. So there are these three ways by which we can reach the third step. And if you think about it, let's say we want to reach the sixth step. So to reach the sixth step, either you are coming from fourth step by taking a double step, or you are coming from the fifth step, right? There is no other way, like there is no way you can reach from third to sixth directly. So for any position n, the number of ways will depend on how many ways by which you can reach the n minus 1th position, plus how many ways you can reach the n minus 2th position, right? In case of this example, to reach 3, we need to know how many ways are there to reach the first position and how many ways are there to reach the second position. If we add them, we know that these are the number of ways by which we can reach the third position. So this is a classical dynamic programming problem, and we're going to use a bottom-up approach to solve this. So let's get back to the solution and let's start coding it. So I think this should be pretty clear by now how we are going to approach it. Yep. So let's start solving it. What we can do is we can create a ways array, and this array will contain its index will represent, let's say ways of I will represent that how many ways are there to reach the ith position. So ways of n will be how many ways are there to reach the nth position. Okay, and it will be, the length of this array will be n plus 1, because when we as arrays are zero index, so if we want to return the ways of n, then we need to make the size as n plus 1. So this ways array, as I mentioned, will contain the number of ways by which you can reach any position. We need to add our base condition. So ways of 0 will be 1. So there is only one way to reach the bottom position. So that is, we are already there. We cannot climb any steps to reach there. And ways to reach 1 will be 1, as we can see, because we can climb only one stairs. So let's iterate through it. We can iterate from 2 int I equals to 2 int I, let's see, yep, 2 int I equals to less than equals, int I less than equals to n, and it will be less than equals to because the size is n plus 1. Yep. So what we need to do in this loop is we need to see, so ways of I will be how many ways are there by which we can reach I minus 1, plus how many ways are there to reach I minus 2. If we are able to calculate this, we know there are these many ways to reach ways of I, so ith position. So once this loop finishes, we can just return ways of n from here, and that will represent the number of ways by we can reach the nth position, and we are done for the problem. So at the end, like in the last iteration of this loop, it will calculate ways of n, and that is our solution. We will return it from here, and I think this looks good. This should work for us. Let's run it. Some error. Oh, I think I missed closing this bracket. Just a second. Now let's run it. It should work. So pretty simple problem if you know dynamic programming. Yeah, so it works. Runtime is 0 ms. It is faster than 100% of Java online submission for climbing stairs. The time complexity is of n and the space complexity is also of n, but we can reduce the space complexity because we are creating this Waze array of size n plus 1, but we do not need the entire array, right? We just need the Waze of previous two position. So we can create three variables. One will be current step, other will represent current step minus 1, and the third variable will represent current step minus 2, and we can keep on like assigning this variable with the latest values, and in the end the current step will represent how many ways are there to climb the nth step. So this is a homework for you to solve it this way and make the time complexity as O of 1. So this is how you solve climbing stairs, a question being asked in interview of Amazon, Facebook, Google. So if you have any doubt or if you want me to solve any other problem, you can comment that below and I can take a look. And I think I'll see you next time.